All right, we can get started now. Before I start, I just want to kind of see everyone's experience, or if you've worked with pre-trained models before, just to kind of gauge the level, like everyone's level in this topic. So who here has like never done anything with machine learning models, anything? Okay. And who has kind of dabbled in it like a little bit? Yeah. And who here is like an expert? Okay. Yeah. Well, but yeah, so pre-trained models, it's a lot less intimidating than you actually think it is. I know when people hear like the word machine learning, deep learning, they get kind of like freaked out. It's like, oh, a lot of math, but not for pre-trained models. Okay, so here's kind of here's a quick table of contents of what we're gonna do today. We're gonna have an overview of neural networks, and then I'll talk about what is pre-training. Then I'll give you a little bit of the motivation as to why we want to use it. And finally, kind of a demo / walkthrough. All right. So an overview of neural network. Does anyone know what it is? Yes.
Oh, what a neural network is?
Yeah.
I mean, it's a series of nodes and weights that are multiplied like by matrices, weights, and it's kind of like, let me explain this.
No, it's good. It's good.
Inputs get multiplied by weights. Weighted sum goes into these nodes, and that serves as an input to aggregation outputs, which serve as inputs to the next layer, so on and so on, until some output that is like some either like a classification value or like a real value or whatever.
Yeah, I mean that's actually a great definition. So it's basically kind of a computing system, and it was inspired by biological neurons. And in a sense, you can kind of think of them as artificial brains. They can do really, really amazing things. And I guess some of the use cases that you would want to use deep learning over classical machine learning is when your inputs are very complicated. So for example, you might have heard of deep fakes, or if you want to handle videos, audio files as input, you typically would go for deep learning rather than classical machine learning. And classical machine learning is typically more statistical, but they're very tractable. So you actually understand almost everything that you're doing. Whereas neural networks sometimes is kind of, I guess, blurred, where you might not know exactly what the model is thinking, but you just get the output. And one of the downsides, though, is that neural networks typically require a lot of data, and they're pretty computationally expensive to train on. So you would always need like a GPU or cluster of them. If your model is very complicated and you want to speed things up, then you need a lot of computing powers. And over here at the top, you can kind of see a diagram of a neural network, but don't worry, it really won't be this difficult. So don't get intimidated by all the notations. Okay, so now when you have a neural network, you're going to train it, right? So like you mentioned, you have the input and the label or a target. And basically you would feed an input to the hidden layer, and it will try to predict something. It might be correct, it might not be correct. And then you compare it to the true value of it. So for example, you find something that's pink, small, and then you pass it through the hidden layer, and it gives you not buy, or that's what the model thinks, but you actually bought it. So there's a slight difference, and then you would go back and change the weights in the hidden layer to kind of predict buy. And you would kind of do this for a lot of examples, to a point where you feel your model's like doing good. So that was kind of a quick and very, very high level overview of what neural networks are. So now we're going to talk a little bit about pre-training. All right, so here's kind of like the life cycle of a deep learning model. You will first want to design a model. So typically you will want to choose an architecture to follow. For example, if feed forward neural network, convolutional, long short-term memory, transform, and so on. And you would also want to pre-process your data before you actually train it. So the architecture, it might sound like a lot of words, but typically you would choose it based on what kind of problem you're solving. So if your problem is very simple and it's just straight up numbers in kind of a general like table way, then you would just want to use a feed-forward neural network. If it's images, people usually go for convolutional, and if it's like sequential, LSTM, where transformers would be kind of the go-to architectures. And then you would go into the training and validation step. So after kind of deciding your architecture, you can code it in whatever library you want, PyTorch, TensorFlow, and so on. And you would kind of use your pre-processed data, clean and kind of scaled depending on the needs. And then you would train and evaluate your network. And this step usually takes a lot longer than anything else, because you would need GPUs or clusters of them for more complex or bigger models. So for example, like ChatGPT, the training time for that is probably like really, really long. But the reason why you guys can use it is probably because they save the weights after they trained. And that's why it feels very fast when you guys use it. And that kind of brings me to the third step, save the weights. So it's kind of like a Command S on your Word document. You kind of want to save your progress. And at the end of the day, neural networks are just a bunch of numbers. So if you know the numbers, then that's kind of the model itself, right? But changing the numbers, that's what makes it very computationally expensive. Okay, now let's kind of dive deep into the motivation of why pre-training. Does anyone want to guess why it might be useful? Any volunteers? Yes.
The model already has like the trained weights, so it knows like it already has data that's already been fed in, so you don't have to train it yourself.
Yeah, I mean, that's actually like a perfect answer. That is one of the huge reasons why we would want to have pre-training models. Yeah, so it's like efficiency and speed is kind of like a really big part. It kind of gives you a really good starting point. So like if you're running a marathon, it's like taking a taxi to 99% of the road and then kind of jogging the 1% left, if you want to. So when you have pre-trained neural networks, you could use them out of the box, or you could also decide to train them on your data to kind of make it a little bit better. But the point is that it significantly reduces the amount of data and training time that you need. And then number two, there's actually something called transfer learning, which is a little bit different. So a lot of the pre-trained networks, for example, if you've heard of GPT-4 or AlexNet or so on, these are really, really big models. And you can kind of say that GPT-4 is a more general model. It kind of contains knowledge about a lot of things, right? But now say that you want to specifically create using GPT-4 to kind of make it into a chatbot or like a therapist, you can actually use the entire model and then kind of replace the last few layers. And then you can fine tune it on therapy data or kind of like a specific use case that you want. And that's called fine tuning your model. It requires a little bit of skill because sometimes it's kind of like doing surgery to the model. But this actually does work really well to kind of, you can train a general thing and then use it for different cases. It actually kind of saves a lot of time for like a lot of engineers, and it's generally kind of like something that people really want to have, especially when you're kind of doing vision or like natural languages. Your computer won't be able to process that much data. Okay, so now I'm gonna go through a walkthrough rather than a live coding demo, because there's quite a lot of things to memorize. And if this is your first time, I guess, working with these packages, don't feel intimidated. It's a very, I guess, structured format almost. And you can probably just ask ChatGPT for most of the code, genuinely. I mean, deep learning, I think this is one of the things where your design and idea is more valuable than your code, because the code is very standard for most things. Okay. So here's kind of like a quick overview of the code. So don't get scared. In this repo, we have static templates, which is the front end part. So I'm not going to dive deep into that. I'm going to specifically talk about app. Okay. So this is using Flask and TensorFlow. Have any of you guys worked with Flask or TensorFlow before? Flask? Yeah, Keras? Yeah. Okay, yeah. So then, is everyone here familiar with web application, web development, like a little bit? Okay. So typically the process is you create your own model, you train it, you have to wait. Okay, now what do you do? Because you can't really submit that for a hackathon, right? You have to put it into like an application to make it like usable or worth it. So this is kind of the main idea is you would want to, I guess like run your Flask app and then kind of use the model inside of it. And it's kind of like using like a library or like an API. So I'm going to walk through a little bit of the code. So over here, this part is commented out. But if you were to copy, clone this repository, you probably would want to run this line first. I think it's in here. Yes. So basically what this line says is from TensorFlow, and TensorFlow kind of integrated with Keras and applications and ResNet. ResNet is a specific vision, I guess like library. And over here, you kind of just want to initialize it. These things you can definitely find online. And then finally, you want to save it. And typically the file format is H5. I guess that's kind of specific to TensorFlow. So once you have it over here, you can see I have my ResNet 50.h5 in models. You can obviously download like different ones. Okay, so then starting from here, you would want to define a model path, load the model, right? And then start running your Flask app. Okay, so now the first interesting function that you will encounter is model predict, right? Model predict would basically take an image path and a model. And typically you would want to load the image and kind of pre-process it like a little bit, which is what these two lines are doing. So the image gets transformed into numbers because that's how I guess like networks can take it. So there's different methods of transforming different types of data into numbers. I mean, even audio files can be, I guess, like transferred into numbers, right? And the pre-processing input part is kind of necessary because I guess without the correct format, your model won't be able to predict anything. And then you simply just call model.predict. I mean, the .predict is specific to TensorFlow, and it's kind of like throwing that image into the pre-trained network, and then it will spit out whatever the model is designed to, and that's what you would return. So this here, everyone finds it simple, or any questions? Okay, so this is an image example, but you could actually do like pretty cool stuff. The image path could also just be a number. For example, predicting your height based on your weight. That could, your weight could be the image path, or I guess like predicting the price of a house based on square foot. And that could just also be in here. So this is just kind of a general format. You guys can change it to whatever you need. And then over here we have the routes. Okay, so the first one is the kind of the homepage. That one's not very interesting. Now this is the more interesting part, is you kind of go through the post request, and over here, this is specific to this app, is that they're just pulling images from the folder uploads. And over here, they make the prediction and kind of return it. So that's sort of the gist of this code walkthrough. Now let's kind of take a look at what it looks like. So this is kind of what it looks like so far, right? I mean, it's pretty bland, but here's kind of the cool thing that we want to work with. So you would click choose, and for example, we can start off with this picture, a cute dog. Okay, so you see, you can already see that the image got distorted a little bit, right? And that's kind of the pre-processing part, because in certain networks, you can only work with the predefined like number of features or size of image. So then what you would have to do is you would have to actually like shrink the image or kind of sample like different pixels from it. But then there are also some models that are very flexible to the different size of inputs that you can get. Okay. So you can click predict and result. Ciao. I mean, I think this is wrong, but you guys kind of get the idea, right? I think it's a Pomeranian. I'm pretty sure. Okay. But you know, we can try a different one. Let's see. Let's try this cat. This cat image is actually pretty nice because I think it does fit the size correctly. So let's try to predict this. And a tiger cat. So I think this is actually pretty accurate, and you can honestly play around with it with like more images if you want. But today I guess like I just wanted to show you two examples. It's not perfect, but it is really good. So that's kind of like a quick demonstration of how this works. If you want to, I guess, play around with this, I will send the link to the repository in the Slack, and you might have to do some changes to that repo. So number one, you need like a models directory, and you would also need a uploads directory. So initially, when you clone it, you would sort of only have app templates and static, and you will also have to add TensorFlow in front of the Keras. The reason for that is mainly because Keras kind of stopped developing and it got integrated into TensorFlow. So the newer version, you kind of have to just pip install TensorFlow instead of Keras. It's going to take a little bit of time when you do it because TensorFlow is pretty big. And I would highly recommend you to use maybe like a Conda environment to help you manage your different like dependencies. And this is pretty standard. And over here in demo, I would suggest you to kind of have like this over here. So this is kind of like a download. You have the file, move it into models, and then you can run this. All right. And for the images that you do want to predict, or I guess like try to classify on, you should probably have a uploads directory, and you want to put the images like in here, right? So you have like these images here, and that's how it can find the images. I spent a little bit of time debugging yesterday because I didn't know you had to specifically put it in uploads, but that's one of the limitations. Yeah, and you can get pretty creative with like some models. You can find some pre-trained NLP ones that are pretty cool. So I think that basically kind of concludes the demo. But if anyone has any questions about like deep learning or these models, you know, feel free to ask. I focus more on the research part and actually building the model, so this is also pretty new to me. Yeah. Any
second model that you use, I guess you probably should pick this one. So what's the decision making process? Be like, oh yeah, I want to use model like models, wasn't it? But how do you know that's the one to
okay, yeah. So well, yeah, that's a very good question. Number one, you kind of want to identify what you want to do first over choosing a model, right? I mean, do you have an idea of like what might you want to use like a pre-trained model for?
Like let's say I want to go classify as
Yeah.
cats and dogs. Like,
Yeah.
do I like Google like model that classify as cats and dogs and comes up with that resonant 50 or like how does that like is resonant 50 like specifically with like just general image categorization? How fine grained are the models?
Oh, okay. that's a very good question. So yeah, there's in machine learning or deep learning, there's kind of like papers coming out about different types of models, and there's certain classifications that says, hey, this is like state of the art. So typically you would kind of choose based on that. Like you would have a list of things, and resonant would be on one of them, especially for images. It's kind of like a really general model because it has been trained on like millions and millions of images. So
like shoe picture.
Yeah.
To this, how guys shoe.
Yeah, most likely. Obviously it has some fault to it, but yeah. Like typically the decision process is you would pick the state of the art if you're just trying to integrate like ML into your apps. You wouldn't really be the one building it. And if you were to kind of do the research and build your own model, you can use this as like a benchmark. So your goal could try to be like, oh, I want to beat this model or something. But yeah. I mean, this one's actually really cool. You can also pre-train it to like specify, what kind of dog it is, what gender of the dog, and stuff, the emotion of the dog. Like you can do a lot of cool stuff with it, and that's kind of like but you might have to fine tune it. Yeah. Any other questions? Could be anything related to the workshop. It doesn't really have to just be about the workshop. Yeah. Yes. Yeah. Oh, so this is pretty interesting. In CTC, we actually don't use the pre-trained models and stuff. Mainly because there hasn't really been a need for it. The pre-trained model was kind of my idea of a workshop because I guess my specialization is in like machine learning and stuff, so it's what I felt more comfortable presenting. But I didn't want to go into kind of the development of the model because I thought that wouldn't be as useful for a hackathon. So it's kind of like the introduction of like, how do you actually just use one that someone already made? Yeah. Questions? Yeah. No. Yeah.
Like this is like the web app is made with Flask, and like is it possible like have like these pre-trained models inside like a XJS project or something like that? Like is there stuff online that teaches how to do that?
Oh yeah, probably. I mean, the reason I use Flask over here is not because it's the only thing you can use. It's actually just because it's kind of the only thing I know how to use. So but I mean, I'm pretty sure that like you can have these different things. I know for TensorFlow, there's actually something called like TensorFlow.js or something, where it's meant to be like pretty lightweight, where like it's supposed to work with JavaScript. So you can get really, really creative with this. And I haven't really done it, but I can guarantee you that you can find it online. Yeah. ChatGPT is actually great for this too. Anything structured, like I would just say trust it half the time, and you might have to spend a little bit of time debugging, but it'll be pretty fast. Yeah.
What kinds of stuff do you do for your actual
Okay. Yeah. So when it comes to like research, you typically will want to use PyTorch instead because you have a bit more control over like everything. So a current project I'm doing is antenna array optimization. So you basically get a lot of like antennas and you're trying to find the best shape. And that kind of requires different techniques, but that is solely focused on training the model. And to be honest, I actually don't really know how I would deploy it.
Yeah.
Because it's more for, I guess, like academic purposes. People don't care as much about deploying it. But typically you would tinker with like design choices. So say like you identify a problem and you're like, this should be a transformer problem, right? You can change the architecture of the vanilla transformer to make something different. And that's just kind of like part of the research. Yeah. Yeah, highly recommended. Any other questions about, I guess, like anything? Concerns, comments. Yeah. Oh, yes, go ahead. Mhm. Mm, okay, yeah. So I think if you were to search, you will find something that might have like the boilerplate code, but not necessarily specific to what you're asking sometimes. By standard, I kind of mean like when you create like Flask, there's kind of a format to it. So you kind of see that like you define the app at first, and then the only difference from like a regular Flask app is you have like this function model predict, right? So it's kind of like an extra step of how do you take data and use your model for it. That's what the function is basically kind of taking care of. So I think that's the main difference. And some of your routes might be a little bit more complex because you have to, I guess, like find a way to really load the data. I think that's actually the hard part, is to find a way to like load the images and stuff and actually use it. So by standard, I meant more so like kind of like the Flask format and also how you would integrate the model, but there's a lot of variety to it. So sometimes some projects get like really big. It might be a bit harder to kind of understand what like that code is doing exactly. Yeah.
So for this one, I don't know, if this is like some repo that you like
Mm.
follow and tweak yourself.
Yeah.
Okay, I see. So then like, if you were gonna take this and change the model, to, like not the image processing, but
Mm.
audio or something like that.
Yeah.
right? Like, you would just like go and like muck around in like your upload and like your
Mhm.
processing stuff and find another model that would be more suited for, this is like an energy model.
Yeah.
right?
No, I mean, you're absolutely right. Like if you were to want or if you want to do like an audio one, what you could do is change this over here, download an audio model, and then change here, or you're changing mainly kind of like these two lines. Well, I mean this one too, because this one's image specific, but you just change the way you pre-process it, turn it into numbers, throw it into the model.
So then, on line 49, like mode equals cafe, right? Like, is that just like something that you found that was like relevant to image processing? Is that what that is? Like,
Okay, yeah. So this is actually like I'm gonna be honest. This line was from the original repo. Okay, but based on the function, I can tell you that this is like a pre-processing step, right?
yeah.
And I mean, I guess like cafe could. Well, I know that cafe used to be like the kind of go-to package before TensorFlow and PyTorch. So the mode cafe could indicate like this is kind of like the standard format back then or something. But yeah, like you might have to look up Google like a little bit how to pre-process like audio files if that's what you want to do with. But kind of like this line though, the predict part, that's pretty standard. Like once you pre-process the data, you throw it in like the predict method. Any other questions or like any curiosity that you have? All right, if we're all good, I guess we can end the workshop early, and you guys, I can send the link. You guys can try to play with it, and like if anything, I'm also here to help for like the next 25 minutes. All right, sounds good.